Welcome to a deep dive into AI. We're going to be looking at this paper, OS Genesis, Automating GUI Agent Trajectory Construction via Reverse Task Synthesis. So basically, teaching AI to use computers just like we do.
Yeah, it's a really significant step forward in what we call digital automation.
Right.
Being able to have AI that can navigate the digital world seamlessly.
This research tackles a big challenge, though, right?
Yeah,
Getting the right data to train these AI agents.
absolutely. I mean, traditionally, we've either had to rely on, humans labeling every single step the AI takes, which, as you can imagine, is incredibly time-consuming, or we use AI to just execute these predefined tasks.
So it's kind of like practicing your driving, but only on a closed track. It's helpful, but not exactly realistic.
Yeah, and that's where OS Genesis comes in. It takes a totally different approach.
Right.
It lets the AI kind of play around in a simulated environment. It can click, type, explore, just like a curious human would.
So the AI is like discovering new ways to use a computer on its own.
In a way, yeah. This is where the reverse task synthesis idea comes into play.
Hmm.
So the AI observes its own actions and then retroactively figures out what task it was actually performing.
But how do we ensure it's learning the right things, not just picking up any random action?
Well, that's where the trajectory reward model, or TRM, comes in. It's like a built-in coach that gives each sequence of actions a score based on how well it achieves a specific goal.
So the AI learns what works and what doesn't and focuses on the interactions that actually lead to something meaningful.
Right. And to really test this out, they put OS Genesis through its paces using two benchmarks: Android World, which focuses on mobile tasks, and Web Arena, which is all about web tasks.
Get it how to do.
The results were pretty impressive. The AI trained with OS Genesis was significantly better at completing tasks than AI trained using those traditional methods.
How much better are we talking?
While on Android World, it was nearly twice as successful.
Wow, that's a huge improvement.
Mhm.
So what stood out to you the most about the results?
I think the most fascinating thing is how OS Genesis creates this incredibly diverse training data. It's not just learning faster, it's learning a wider range of skills than we've seen before.
So it's able to explore more options and discover subtle functionalities that might be missed with those human-designed tasks.
Exactly. With traditional methods, even with human input, you tend to stick to familiar patterns. OS Genesis breaks free from those limitations and achieves a high level of diversity in both the instructions and the actions it takes.
And that seems like a really crucial advantage in creating AI that can adapt to new situations.
Absolutely. The researchers even found that when given human-written instructions, the AI actually performed better using the ones generated by OS Genesis.
So it's not just mimicking human actions. It's about understanding the goal behind those actions and figuring out different ways to achieve that goal.
Right. And to really understand the impact of that trajectory reward model, they compared it to a couple of other approaches. One where there was no reward model at all, so all data was treated equally, and another using a labeler where only complete trajectories were considered.
And what did they find?
Well, the TRM was especially helpful in enhancing those high-level capabilities, the ones needed for those more complex tasks on Android Control and Android World.
Right.
And actually using a labeler actually decreased performance on simpler tasks. So it really highlights the importance of having that graded evaluation system like the TRM that can learn from even those incomplete actions.
It's interesting that throwing away data from those incomplete attempts could actually be throwing away valuable learning opportunities.
Yeah, and they also looked at the relationship between the amount of data and the AI's performance. As you might expect, more data generally led to better performance on tasks, but there were limits to how much improvement you could get just by increasing data size.
So kind of a point of diminishing returns.
Right. And they speculate that this could be due to a few things: limitations in the AI models themselves, constraints within the exploration space, or even the ability of GPT-4o, which is a very large language model they used in this research to actually translate those high-level instructions into executable actions.
It sounds like there's still some bottlenecks to overcome, but the potential is definitely there.
Oh, absolutely.
Yeah.
This research offers a really compelling glimpse into a future where AI can truly understand and navigate the digital world on its own.
And of course, no research is without its limitations.
Right, of course. There are a couple of limitations to be aware of with this research.
What are they?
Well, one is the reliance on those proprietary models, like GPT-4o, which we've talked about. They do acknowledge that open source alternatives right now just don't have the capacity for this type of exploration yet.
They are hopeful, though, that as those open source models advance, they'll be able to take on these roles.
Yeah. And another thing is they used both textual and visual representations to train and evaluate the AI agents. This helps ensure consistency across different environments. But it does raise the question of whether using just textual or visual data alone could be equally effective.
Sounds like a good avenue for future research.
Definitely. It's clear that this research is pushing the boundaries of what AI can achieve. It's pretty remarkable.
It really is. This idea of letting AI learn by doing and then reflecting on those actions to extract meaning has the potential to revolutionize digital automation.
Yeah, the paper actually goes into a lot more detail about how this, what they call interaction-driven functional discovery actually works. Would you like to delve into those details a bit further?
Yeah, let's really dig into that a bit more.
Yeah.
How does this interaction-driven functional discovery actually work?
So, in this initial stage, right, the AI is basically exploring the GUI environment. You can think of it like systematically clicking, typing, scrolling through different elements, just like a human would when they're trying to learn how to use a new application. And this is happening in both Android emulators and web browsers.
So it's not just clicking around randomly. There's a method to this exploration.
Exactly. It follows a rule-based approach. The only exception is when it's interacting with those input fields, like text boxes. That's where it uses GPT-4o to generate content that's actually contextually appropriate.
Makes sense.
Yeah.
You wouldn't want it just typing in gibberish into every text box. So what's the outcome of this exploration phase? What does the AI actually end up with?
It results in this massive collection of what they call triplets, and each triplet contains the state of the interface before an action, the action itself, and then the state of the interface after the action.
So it's like building a record of everything it does and the consequences of those actions.
Yeah, and these triplets are basically the foundation for the next stage, which is the reverse task synthesis.
Okay, so we've got all these actions and state transitions.
Yeah.
Now, what happens in this reverse task synthesis?
Essentially, we're taking those observations and turning them into understandable task instructions.
How do you actually go from those triplets to task instructions, though?
So it's a two-step process. First, they have this annotation model, which is also powered by GPT-4o, and it generates what they call low-level task instructions for each of those triplets.
And what do those low-level instructions actually look like?
Basically, they describe the specific action and its immediate effect. For example, if the action is clicking a drop-down menu, the low-level instruction might be something like click the drop-down to display options.
So it's like a play-by-play of what the AI is doing.
Huh.
But then how do you go from that to understanding the overall goal?
That's the second step. We need to connect those low-level actions to a bigger picture. Basically determine what they call the high-level task instruction. So in that drop-down menu example, the high-level task might be something like configure application settings.
Because clicking that menu is part of achieving that broader objective. Right? So this reverse task synthesis is really about understanding the why behind the what. It's what allows OS Genesis to generate those diverse high-level instructions we talked about earlier.
Right, and to really dive into that diversity aspect, they did an in-depth analysis comparing the data generated by OS Genesis with data from those task-driven methods and also human-annotated data.
How did they actually measure the diversity of the instructions?
One way was by looking at the variety of the instructions themselves. They used a technique called sentence BERT to analyze how different the instructions were from each other.
And how did OS Genesis stack up? Did it produce more diverse instructions compared to the other methods?
It did. And they also looked at something called trajectory diversity, so examining the sequence of low-level actions taken. And again, OS Genesis showed the highest diversity, which suggests that this exploration approach leads to a much more thorough understanding of how a GUI can be used.
That makes sense. It's not just about the variety of tasks. It's about the variety of ways to accomplish those tasks.
And while the human annotated data showed a decent amount of variety in the instructions, it lacked diversity in the trajectories. Humans, we tend to be creatures of habit, even when we're trying to be creative.
We're good at imagining different things to do, but we often stick to familiar patterns when we actually do them.
Yeah.
OS Genesis doesn't have those limitations.
Exactly. And another interesting comparison they made was looking at the average word count of the instructions. For the mobile tasks, OS Genesis produced instructions with an average of 18 words, which is pretty close to the 18.7 words in the human-written instructions.
So it's not just spitting out random instructions, it's creating instructions that are comparable in detail to what a human would write. That's pretty impressive. What other interesting insights did they uncover about the types of instructions that were being generated? What other interesting insights did they uncover about the types of instructions that were being generated?
Well, one thing they found was that OS Genesis tended to lean more towards those task-oriented instructions, the ones that focus on achieving a specific goal, whereas the human annotated data often included more of those question-oriented instructions, aimed at finding information. So it really highlights OS Genesis's strength in training agents to actually perform those complex multi-step tasks.
So it's not just about knowing what to do, it's about understanding how to get to a desired outcome.
Right. And as we touched on earlier, one limitation is the reliance on those proprietary models like GPT-4o.
And they're hoping that as open source alternatives become more sophisticated, that they'll be able to handle these tasks.
Yeah, they believe that incorporating those open source models as they mature would really make OS Genesis more accessible to a wider range of researchers and developers.
Well, this has been an incredibly insightful look at OS Genesis. It seems like it's a significant step forward in developing truly intelligent and adaptable AI agents.
It has been a pleasure diving into this research with you.
This research really gives us a lot to think about in terms of the future of AI and how it interacts with the digital world. Thanks for joining us for this deep dive into OS Genesis.